Hi guys. In this section of our probability lesson, we're going to take a look at the fundamental principle of counting. The fundamental principle of counting gives you a really quick and easy way to find the total number of ways there is to complete a task. So let's say that we have an event that we're interested in, and there are m possible outcomes, and another event has n possible outcomes. Then the fundamental principle of counting says there are m times n ways to do both. So basically it says take the number of ways to do one thing and the number of ways to do the other thing, multiply them together, and you get the total number of ways to do the whole thing. So let's look at an example. You and a friend are in the mood for frozen yogurt while in Nacogdoches, so you head over to Chili Fillmore's. May or may not be my kid's favorite place. One of their machines is down, so you only have 5 flavor choices. There are 20 possible toppings and 3 flavors of syrup. How many combinations can you make if you get to choose 1 flavor, 3 toppings, and 1 kind of syrup? So let's take a look at what we've got. We get to pick a flavor. We are picking 3 toppings. We'll call this T1, topping number 2, topping number 3, and then we get to pick 1 flavor of syrup. Okay, the fundamental principle of counting says that if we want to choose 1 flavor, 3 toppings, and 1 syrup, we need to take the number of ways there are to do each of those things and multiply it all together. Well, they only have 5 yogurt flavor choices right now. So there are 5 ways to choose a flavor. Now for my first topping, I have 20 ways to pick the first one. For the second one, it doesn't say I can't repeat. So I still have 20 options for the second topping, and I still have 20 options for the third topping. So if you want triple sprinkles, great. You can use all 3 topping choices for sprinkles. Then the last part says they have 3 flavors of syrup. So there are 3 ways I can choose a syrup. The FPC says we need to do 5 times 20 times 20 times 20 times 3. Because I love you guys, we are going to plug this into Desmos instead of me trying to do this in my head. Look at that, y'all. The fundamental principle of counting says I have 120,000 different ways that I could choose 1 flavor, 3 toppings, and 3 syrups. So now let's look at 9. For 9, you are cleaning out your closet. This is something I desperately need to do. You leave only 5 shirts, 4 pairs of pants, and 2 jackets. How many outfits can you create consisting of one shirt, one pair of pants, and one jacket? So I'm going to start it off kind of like we did the last one. We want to choose a shirt. I get to choose pants. And then I'm going to choose a jacket. Well, I have 5 ways I could pick a shirt. I have 4 pairs of pants. And I have 2 jackets. This one isn't so bad. I can multiply these together on my own. 5 times 4 is 20. Times 2 is 40 different ways we could combine one shirt, one pair of pants, and one jacket. The last part of probability we're going to take a look at is the complement rule. And this is not a rule that goes around and telling all of the other rules that they are looking especially concise or they have a great smile. We're not talking about that kind of complement. We are talking about a complement that sort of completes something else. So the complement rule says if the probability of event A occurring is P of A, then P of A complement. This says probability of A complement, or you might hear some people say A prime, is equal to 1 minus the probability of A. The other part of that, and I think I made the lines way too long, but that's okay. The other part of that is that the probability of A plus the probability of A complement is equal to 1. So if you know either A or A complement, you can find the other one by subtracting from 1. An example of this might be the forecast. If you have a 30% chance of rain, the probability that it's not going to rain, so the chance for no rain, would be 1 minus that chance that it's going to rain. So you would have a 70% chance of no rain. That's kind of how the complement rule works. So if we have the probability of choosing a correct answer on a multiple choice problem, well, if we can only pick one, there's one correct choice out of 4 choices. Well, that means the probability of choosing the incorrect answer would be 1 minus 1/4. If you go plug that into Desmos, you get 3/4 or 0.75. A box of brownies from 903 Bakery is sitting on the table. It contains 4 peanut butter brownies, 6 red velvet brownies, 3 double chocolate cupcakes, and 1 giant frosted cookie. What is the probability of selecting a peanut butter brownie from the box without looking, and assuming you don't have a peanut allergy? If you have a peanut allergy, we know you're not going to pick that one. In order to find the probability of selecting a peanut butter brownie, we need to know how many peanut butter ones there are. It says that there are 4. out of a total of 4, 10, 11, 12, 13, 14 objects in the box. Now we can reduce 4 over 14 by 2 in the numerator and in the denominator. So you have a 2 out of 7 possibility for pulling out a peanut butter brownie if you just stick your hand in there. And the probability of not choosing a peanut butter one, so the probability of getting something else, would be 1 minus 2 over 7. Well, that's the same as 5 over 7. So you have a 5 out of 7 chance of choosing something that is not a peanut butter brownie.